Matteo, can we make it any faster?
Of course we can. We have extreme mode, okay? So you can even go faster if you want to ride the bleeding edge. So in extreme mode, we can log 10,000 ops, 10,000 logs in 100 milliseconds, which is more or less 2 times improvement over throughput improvement over the previous, the normal mode. Let's run some maths. Yes, it's nice. Okay.
But there's a trade-off.
There is a trade-off. The trade-off is we have 4 kilobytes batching. So you might lose 4 kilobytes of logs.
It's a small chance. But
it's a small chance, especially if you segmentation fault, you lose it. If you have an uncaught exception, you don't lose it. So if the error is in JavaScript word, we catch it, but there is a less case where this is not flashed on disk.
Power cut segmentation fault,
yes,
I guess.
power cuts, segmentation faults, and so on. So,
and if you're doing huge amounts of logging, you might be willing to take that risk.
Yeah.
Basically.
So you just need to trigger it, enable it, extreme true. And if you log something, you probably won't see in the output line if you're running it in development. So enable it all in production, okay? Leif, let's talk a little bit about the server integrations.
Yes, okay. So we wanted to make sure that the third-party pieces, because we noticed sometimes with the ecosystem for the other loggers, sometimes the logger was fairly decent in terms of performance, but then the middleware for it would be bad performance. So we created the middleware, the server web framework pieces. So we have Express Pinot Logger, Happy Pinot, Resify Pinot Logger, Koa Pinot Logger, which works for Koa 1 and 2, and then we have Pinot HTTP, which is essentially just works with the raw HTTP module. Essentially what these loggers do is they will log each request automatically. So that's pretty nice. In terms of the rest of the ecosystem, we also have transports, serializers. We built something recently, which is the slide we forgot to add.
Yeah.
Recently released something called Pinot Noir, which was Emily Rose's idea. It's
thank Emily.
You know, it's a play on words. If you need more, ask Emily to explain it. But essentially, it allows for redaction of logs in the fastest way possible. So we're addressing the different sort of logging sort of scenarios and problems and doing them in the most performant way we can. When we have contributors like James Summers, they come and they do stuff, but we kind of coach them to do it in the most performant way. So if you're interested in contributing, go ahead, but tag us in the issue and stuff, and we'd be more than willing to help out with building it. And
it's also
a great way to learn how to do performance.
Yeah. So if you want, for example, write a new transport, or you want to integrate with a new framework, or do some log processing or whatever, contact us, and we can work out on a model with you, new module with you that is exceptionally fast as well.
Yeah. So we're going to talk about the tools of the trade.
Yeah.
Is this me as well?
This was
okay.
you, yeah.
Oh, yeah, so flame graphs. We know about flame graphs. Well, 50% of us do.
The ones that don't, you will see now.
Yeah, so I created a tool called 0x, which basically allows you to capture the stacks, both the C and the JS stacks of a process, and visualize them in a flame graph. So a flame graph is essentially a representation of functions calling other functions. Those are the stacks that you can see. The width of each block represents the time that function was seen on the CPU, and then the color of the block, when it's just the orange and red, is essentially an indicator of the amount of time that particular function was seen at the top of the stack for that particular CPU sample. So say sample every 1 millisecond. If you see a function at the top of the stack a lot of times in a row, then it's likely that it's blocking the event loop. What this enables you to do is essentially create a flame graph, look for the red spots, and find your bottlenecks very, very quickly. We created this tool as we were creating Pinot, and we used it to further optimize Pinot.
I have one more thing to add here,
yes.
Dave. It's all of what this tool does, it's not new. What this tool does, it makes it extremely quickly to create this type of visualization. Okay. Before this, you will need to fire up a smartwatch machine, and it requires lots of manual steps. Or another
about 6 or 7 steps usually to create. The other thing was it was really hard to generate flame graphs on OS X.
Yes. This works out of the box in most of the machines. During the workshop, we got a PR to fix it on some issues some people were having on Linux. So it should be fine now. If it doesn't work for your machine, issues, there is one catch that we probably are working on, but I don't know.
Yeah, generally in the main case it works.
In the main case it works, not on Windows, but we are working on it with some Microsoft people. So that's the benefit of conference, right?
So the other tool is this one.
Yes, autocannon. So we were, this comes a little bit later on, and we have been huge fan of a tool called WRK at Nearform. And WRK is a nice tool to run HTTP benchmarking. And it's also what the Node Core does, or it was the main one that it used to use till recently. We developed autocannon because we wanted to run HTTP benchmarking from Node itself. There is some reasons. First of all, WRK was scriptable only in Lua. And as much as I love Lua, I love JavaScript more. And the second was that, wow, why if I write an HTTP HTTP benchmarking node is low? So, well, we wrote it. And in fact, this gives us a nice other property, which is trivial cross-platform installation. It's trivial to install it within it's very trivial to install it on Windows, for example. And it also now can be used to benchmark Node Core, and is part of the benchmarking.
So it's used by the core team for benchmarking.
And it also generates 10 more loads than WRK, thanks to the support of HTTP pipelining, which is a nice feature if you know what that is. So this is a nice combination, is what we covered in the workshop, okay? I'm sorry if you missed it. So I have a demo now, so Dave is going to talk while I'm doing it.
So as I was saying, we were working on the sort of ecosystem parts as well. And in this particular case, we're going to demo Pinot Elasticsearch. What it does is it essentially takes the Pinot logs and it pipes them into Elasticsearch so that they can be viewed with Kibana. So what Matteo is doing now is starting the Pinot server, just checking that it works, doing a bit of a curl request. And you can see that that logs out to SSD out. Now you've already started the Docker containers?
Yes.
So there's 2 Docker containers running, which is Elasticsearch and Kibana. And now he's running Pinot server and piping it to Elasticsearch as a separate process. That's really important. If you try to do it in process, it has a much bigger effect than if you can pipe to it as a separate process. You've just logged one thing, yeah?
Yes.
So now he's setting up an index, and all he has to do is type Pinot as the index, and the field is time. And that allows you to go into, you in the right place?
I don't know, yeah, but it's...
Discover is where you need to go.
Yeah, I know, but it's Chrome did a weird thing.
Yeah. So he goes to Discover, and we can see that there's our first log message. If you break that down, we have the rec ID that's added to each request. So this is an example of our web integration.
So each request in our server integration gets its own subloggers. And this sublogger has a pre-configured ID field. So if you use that to log throughout your application, when handling that request, all the log message will be tied to that original request. So it's really handy if you need to do some debugging at 9 a.m. in the morning on Sundays, or on Christmas Eve, or whatever.
So now you're going to hit it with a autocannon to generate a bunch of logs. 9, 10, and
that's fresh.
Right, now we have all the log messages, and you can break up the graph a little bit as well. Yeah, so you can see, there's a lot of stuff in Kibana. You can visualize, you can do all the different things. Kibana is really cool. But we're creating these different just little integration pieces so that you can use Pinot with other tools. And we're doing it the Pinot way, which we'll talk about shortly.
So Pinot is more than a module. Pinot is a way of life.
So true. So the Pinot philosophy is absolute minimum overhead. As we were talking about the adapter problem, it's that, and it's making choices architecturally sometimes to deliver the best possible performance. So the first thing is rotate your logs yourself. If you use a logger that's rotating the logs in process, you're prioritizing log rotation over answering or responding to requests. That's a backwards priority. So log stash, right?
No, log rotate.
Sorry, log rotate.
Log stash is the other one.
Yeah, the other thing, yeah, sorry. So you use log rotate or whatever you want to use to
It's
rotate
part
logs.
of your Unix distribution, okay, of your Linux distribution. Every server has a nice instance of this daemon called log rotate that was the operating system used to rotate the log of every program. So please don't use any log rotation in your logging framework. It's absolutely not needed.
The other thing to think about is if you are using a logger that does log rotation, you're kind of paying the cost even if you're not using it because of the adapter problem.
And also the fact that if you're using Docker or a system that's running on containers and so on, you probably don't need log rotation anyway. The infrastructure does it for you. So,
if you want better readability, post-process. Don't try to do pretty log printing in your own process. Again, this is a wrong priority. So with Pinot comes with its own little CLI tool. So you can pipe the logs through the Pinot. You install Pinot globally, just pipe them through Pinot, and you'll get pretty printing. This actually is also useful for another trade-off that we made with the dates. Other loggers will do the full ISO string for your timestamp. We do the millisecond epoch timestamp because it's a lot cheaper. But the Pinot CLI, if you really want it, you can run Pinot with -t, and it will change those timestamps into the full ISO strings in your JSON. The other thing is that we keep transports as a separate process. So anything that you need to do, any way you need to pipe your logs, just run it as a separate process. And that's the best way to ensure good performance. There's Pinot Elasticsearch, Pinot Socket.
that was James
as well.
That was James, and also Pinot Syslog. Our collaborator did Pinot Socket and Pinot Syslog. And one is the socket one is really good if you want to set just your log message, for example, to a log stash instance, if you have that, or another just basic TCP server. Syslog is for integrating with the Syslog infrastructure because it's really handy if you are into Syslog anyway.
And your module. This is me as well.
Yeah, let me do it.
You do it.
So when we were writing this, sorry, probably my fault. Anyway, when we were doing
That
this,
was some serious ecosystem impact.
yeah, that was ecosystem impact, absolutely. Like, anyway, when we were doing, doing Pinot, we started benchmarking all the other loggers, and one of them is Bolly. And Bolly is the logger that was written by my friend Rodvag, and we tweeted to him that we wrote a logger faster than it was. And after that, basically said that we have thrown the gauntlet, and he released a new version of Bolly that is almost as fast as Pinot. And in fact, use one of the tricks that we have done, several tricks that we have discovered to make a logger faster.
And whilst we feel kind of awesome about that, the really cool thing is that we provoked improvement in the community.
In the community. Also, some part of the standard logging infrastructure for Happy, all the good family, if you are into it, is starting using some of our modules.
Yeah, fast save string.
Fast save stringify. If you need to stringify a JSON in a safe way that doesn't throw, use fast safe stringify. Is really fast. Okay, it's in the name, so it's fast. I'm telling you. Anyway, let me wrap up.
Yes.
I'm probably late, so I'm sorry. Anyone? This presentation is available on my GitHub.io account. It also has a nice GitHub repo, also with the demos, so you can check it yourself on your machine if it's low or not. And this is me. I don't know, I probably presented myself too much at this conference, so I'm not going through it. I let Dave present himself.
This is me. Go ahead.
Yeah, okay, yeah. We both work with Nearfirm for quite some time now, so we have a lot of fun also, and whatever. Anyway, again, thank you. If you have any performance issue in your application, please contact us. We will really want to help and see if we can make your software faster. Thank you.
Is there time for questions?
I don't think there is any questions in this conference, Dave. Where you were the last 2 days?
No questions, please.
No questions, no photos.
Once we get Gregor up here to get set up, I did manage to write a poem for the both of you.
Oh, this should be good.
Hopefully, we'll see. All right, here we go. You ready?
Yeah.
The cost of logging, which has us just slogging, through libraries which impact our performance, keep it intact. With these tricks, you'll see how to make your logs go wee. Indeed, it's so delightful to see our log buffer quite full, but with a flame graph, we discover something quite frightful. With the cumulative effects of our text-based discovery has led us to a library named after a nice tree. Pinot, you now know, helps your log output flow. No changes we need from Bunyan with speed. So many ops on Matteo and David's laptops. These things are quite serious, just see how it clocks. With Ox, you even see where your event loop blocks. And with AutoCannon, you can see where things get messy. Load test your server, just fire away. Just keep yourself informed and do not dismay. Now here's where things get deep. Pinot avoids scope creep. With a minimalist philosophy, keep logs rotation free.
Outstanding.
Thank you. Thank you to the both of you. It was a beautiful presentation.
Thank you.
If you have questions, I'm sure the both of them will be available.
Thank you, Emily.
Thank you. And you're all set up. That quick. Fantastic. Well, please join me in giving a warm welcome to Gregor.
Thank you, Emily.
Thank you.
All right, great. So my talk title is Turning the Tanker and Navigating Rough Seas. So this is a bit vague. I was invited by Nearfirm to attend NodeConf to talk in the enterprise track. I'm certainly the first talk diving more into the meta level and not the technical level. I hope this fits a little with your expectations. So my talk is more about change, a story about what we did in transformation work. My name is Gregor Rusbild. I'm working on digital at Costa. So, Costa, what is this? You might have heard Costa Coffee Company or Costa Frozen Foods, but have you ever thought about Costa Cruises? So, question up front, who has ever done a cruise in their lives? So can you add up if you think about doing another cruise or your first cruise? So, pretty few people out there. Okay, cruising is a difficult industry. As you see, massive ships. We do have small cities cruising the oceans. This ship is Costa Diadema. It set sails in 2014, hosts roughly 6,300 people, is 300 meters long and roughly 40 meters broad on 18 floors. So this is quite massive thing rocking the seas. So the cruise industry at all transported 35 million guests in 2015 alone on 300 vessels, which is in itself quite small, I would say. But this industry is capacity capped, which means we do have a market where we have more demand than ships on the water. So our industry will be growing by roughly 25% in the next 5 years just by extending capacity. And capacity-capped markets are usually a quite rough thing to navigate, right? Because whenever you deploy new capacity, you will have instant revenue, more or less, even if you do have big investments. This sets for traditional IT not moving, for example, for businesses not thinking about new business models. How do we move forward? Because we can just build new ships and get better at what we do. So digital, in this case, I said I work on digital. Digital can mean a lot of things. So we all can say we work in digital, right? Is it a digital agency in the middle of Costa, which is building some websites or some marketing pages? Is it equals to web? Is it more? On a conference in Hamburg a couple of weeks ago, someone interexchanged digital with artificial intelligence, so equalize it. This is quite interesting because a lot of people think digital moves towards automation, right? Risking people's jobs. And a couple of people don't really understand the core of artificial intelligence. They only think, okay, yes, it's pattern matching, automation, and driving things forward. For us, digital is more about transformation. As a buzzword, everyone has heard it. Everyone wants to do it nowadays. We want to transform ourselves. We want to build a better experience for the customer, right? And by doing this, we want to transform the way we work in ourselves, whereas we are in an industry which hasn't moved for quite a long time. So we set sails and said, let's go forward, full speed ahead. We want to have something small, fast, employed with the best technologies, methodologies, etc. We can have. Maybe you remember this series from Hulk Hogan in the 90s, Summer in Paradise, Speedboat. Great thing. So what we did in 2015 is thinking about what can we do in order to transform this organization. Our unit got founded. We got a lot of people on board with all the knowledge required to go fast, to be at speed, to have fun at work, know what we do, know what we are talking about. But is this really enough to drive things forward? First thing, oh shit, brownfield. I need to integrate with legacy systems. Suddenly, I've got a landscape of 300 outdated systems, which are not properly documented, where people not knowing what's going on in there, side effects, etc. So we were there, going fast, building products, web products mainly, on the first step. And we thought, yeah, it's all right. But suddenly, this legacy kicked in. Rough seas. We had to figure out what to do, right? We saw a little shiny speedboat having fun. We weren't able to persist these weather conditions, right? We needed to pick up. We needed to learn what does it take to be stable on these waters. So at that point, we had to leave our small boat and enter the vessel to understand what's going on. So some learnings on the way. If you work in digital transformation, it's not enough to just build in thin slices. This won't transform your company. So what we tried first is digitalizing a publishing brand which uses catalogs to sell cruises. Quite easy to build something to make it more digital, right? 2 pages, I've got a search, I've got the details, booking, boom, runs. The problem here is it's a very simple slice. The organization in itself never realized what a huge leap forward that was, right? Employing things like continuous delivery, etc. It's a huge success for us, but we didn't change anything of the organization, right? People are still trying to foster and to steal the word here, sorry, to handle us like an agency, right? Dropping in requirements and not focusing on the customer anymore. So next up, what we thought is leveraging technology to break down these silos. So how can you leverage technology whereas you have a big, massive metrics organization doing a lot of things on the one hand, more things even there, some outdated things on your back. You never know what's going on. How can you use technology to bring them all together? So in our case, we thought about the customer. What is the customer doing? What does he need? What can we use in order to navigate around the brownfield legacy systems with something new in order to improve the situation? So in our case, we thought about, okay, we need some kind of integration layer, something which can bring up a new shiny world of microservices, etc., with the legacy systems. And in our case, in the first case, we targeted the user smartphone. Right? We wanted to have a travel companion for everyone where you can receive the information you need right now. So what we did there is thinking towards, I think this is coined by SoundCloud and Saltworks from last year, backend for frontends, right? Have you heard of this, backend for frontends? Is anyone really using it? It's extended, okay, 1, 2. So backend for frontends, the idea is you're building a very thin orchestration layer on top of your legacy APIs, building out a microservice world on the other hand, which helps to reduce friction, makes it easier for your clients who are interacting with this backend to get the data they need. Right? It helps you to move very, very fast from legacy to the new Mode 2 or shiny world. What we employed there is GraphQL. Anyone using GraphQL in production? Okay, GraphQL is basically a declarative data fetching framework, and we are really just using it as the backend for frontends, which orchestrates all our services we need to integrate. The beauty about GraphQL is I do define my data in the client, which I need. In the server or the backend, I do have a schema, which is well-defined, documented. I can see from where the data is coming, and I can pretty flexible shift out the services behind my backend. It's a nice piece of technology. I would encourage everyone to have a look into it. So moving forward, we're using Relay to fetch the data from the GraphQL backend and the React Native application. Because yes, we are not only capacity capped, but resources capped. Right? Having a small team, trying to build a lot of digital products, we want to use technologies which can be employed by the whole teams with JavaScript in the core. So the next thought, after having a product which is used by customers, breaks down silos, makes people work together and collaborate, share knowledge. How can we get this even further to have the idea of one ship, for example? So each ship on these seas is offline by default. We need a reliable way of distributing our applications to bring down the amount of work required on board for IT officers to have their VMware infrastructures running. So right now we're investigating on a nice topic, shipping containers on actual ships. So the backstory here is right now we are piloting Kubernetes in order to have federated clustering above all our 41 ships in the European area, which will give us a huge advantage of deploying applications and having better control over which services running on which ships without a lot of manual intervention. So this will be a huge leverage for us once we're there and we can deploy applications through our chips in ease. We have a much better leverage using the customer as leverage to bring down some of the legacy systems, renovate them, and go forward. I'm doing time-wise. I'm okay. I think that's it from my side. Quite short. Any questions? Anything?
I have a question.
Yes, please. Come up.
How does it feel to be so awesome?
What?
Yeah, how does it feel to be so awesome?
I'm blushing.
Oh. That's it, that's the question.
I can't answer that. I'm blushing right now.
That's a good feeling, right? Yeah. Any other questions from the audience? Yes, you in the back. Right there. Yeah, you. Right. No, that's okay. Don't be shy. He's blushing too. No? All right. Well,
All right.
please, round of applause.
Thank you.
And so while Katie's getting set up, I'll read the poem that I wrote for you. It is a bit shorter, so please, I apologize. But I think I did well.
Okay.
Okay, you ready? Are we ready? I'm nervous. Technological transformation with aquatic transportation. The saviors of a nation are the methods of digitization. With continuous delivery, you now find yourself quite free to innovate in new ways while out in that big sea. And I'll go a little bit further as I have time, but that's what I've got so far. So thank you again.
Thank you very
Please,
much.
round of applause for Gregor.
Thank you.
Hello. Should we? Are we close to being set up, or should I make them stand up again? Say. Oh no. Well, at the request of Katie, I'm going to ask you all to rise, just briefly. Why not, right? I blame it on her, but really, I just like making people do things. That's okay. Yeah, you can sit and stretch too. Let's do just do a quick reprise of the laughing yoga. Everyone, on the count of 3, just strike your favorite laughing yoga pose. Okay, 1, 2, 3. Well, there was some laughter there, I guess. All right.
A little bit.
We'll go with that. All right. So without any further ado, please join me in giving a very warm welcome to Katie from the BBC as she explains how to strangle a monolith.
Okay. Thank you, Emily. So yeah, hi, I'm Katie Roberts. I'm from the BBC in Salford, and I'm going to talk to you today about some of the experience we've had at the BBC of getting rid of our monolithic architectures. So first off, a bit about me. I've been a developer for over 10 years. I became a developer by accident. I was working at Teesside University. I was put in an office with a guy who would only talk about development and Phil Collins. So I learned to program because I wasn't going to learn about Phil Collins for anybody. I've been at the BBC for coming up for 5 years now. I started off as a JavaScript developer in IPTV or the smart TV systems, building JavaScript products for BBC Sport, for Olympics 2012, but I've also worked on BBC Sport and BBC Music stuff. And I'm now development lead for BBC Knowledge and Learning. So BBC Knowledge and Learning, the BBC has a remit to educate and to inform and entertain, and Knowledge and Learning cover the educate part of that. So we've got products such as BBC Bite Size, BBC Food, BBC Art, Earth, Science, Religion. Basically, we are BBC any other business. We're also responsible for the BBC Microbit, which some of you might be aware of. Does anybody here not know who the BBC are? That's the awesome thing about working at the BBC. I never have to explain that bit. Software development at the BBC. There are many different teams in the BBC. So there are news, sport, children's, knowledge and learning, media playout teams. And we're spread across many different locations across the country. So my team is actually split across Salford and Glasgow, but there are also teams in Cardiff and London as well. We create products for across 4 different screens. So by that we mean PC, TV, tablet, and phone. And we've got a lot of large projects, which have been written in a large number of development languages. Previously, the BBC used to write a lot of stuff in Perl, and then they moved to PHP and Java, and now they're moving more towards a Node world, which is great. There's a lot of legacy code. We've got some code bases that have been around for 15 years, in the case of BBC Food, and 10 years for Bite Size. So there's quite a lot of legacy code bases. We have very large audience numbers. So something like BBC Sport will pull in about 14 million unique users a week. The knowledge and learning team, we only get about 5 million unique users across our products. So we're quite a small team in BBC terms. We've got a lot of experience of delivering content to large audiences, and a few people have asked me over the conference how many developers there are at the BBC. So I think that in the software development, including testers and developers, I think there's around 2,000. It's difficult to know, though, because we all work in quite small, isolated teams. So we talk to each other's APIs, but we don't all get together in one room at any point. So I'm not quite sure how many developers there are at the BBC. So we've got some experience with monolithic code bases, and what I'd like to start off with is saying that I don't have a problem with monolithic code bases. The monolithic architecture is not intrinsically bad, and most of them, for the most part, do a very good job. The architectures fall down when they start to try and encompass new functionality or different functionality for jobs that they were never conceived of doing. And you start adding straps onto the code, you're adding bolt-ons, and then it's not documented necessarily, and then that developer leaves, and suddenly somebody else is picking something up, and it goes from being a beautiful, well-thought-through monolithic architecture to something which is more like this. It's got bolted-on code all over the place. It's a towering block of monolithic code that has existed since the dawn of time, or for at least since anyone who is in the building has been around. And when changes are made, the whole thing needs to be retested. It takes a long time to retest because you never know what you've done and what change that might affect and how that will affect an audience member. Content's been bolted on, there's tightly coupled software, and it's not what we want, which is scalable, maintainable, reliable systems, which are more like this. This is how microservices feel in my head. This is not the BBC's view, this is just mine. This is microservices existing on the cloud, which is where I think it's a nice place to be. They're nest coupled systems, and they can be changed, and they can evolve at their own rate. So now I'm going to tell you a story, because I do best when I'm telling stories. So this is the story of Bite Size. Bite Size is one of the BBC's flagship products. It's been going around for 10 years now. Has anybody here ever used Bite Size? Oh, that's nice. It exists in the UK and to help kids from schooling key stage 1 to GCSE level, and it really does form the backbone of our Educate system. So I asked my product owner for some stats on this. So here we go, flying slides. Bite Size has over 5,000 revision guides. It's got 2,500 decks of flashcards, which are used for the mobile app. It's got over 100,000 class clips, which are used for short-form video content for teachers in the classroom. It covers the separate educational system of all 4 nations. So anyone who's done GCSEs in the UK or Scottish Highers will know that there are a multitude of different exam boards, and Bite Size covers them all. It's got 38 different subject areas, and in total that's over 300 separate programs of study, and 5,000 plus topics of studies. 82% of all 15 to 16-year-old exam students say that they use Bite Size, and we pull in around 3 million unique users around the exam time. And 4 out of 5 kids say that it's helped them to feel more prepared for their exams. So that's good. It provides a lot of stuff for a lot of people, but users can find it quite difficult to navigate. So finding your content and what you want to do and what you're studying with that amount of noise around you can be difficult. This is the current bite-size architecture. It's a standard n-tier architecture which was written in PHP. So we've got a number of different services which we're using to access the data content. We've got Equation Chef, which is it renders our equations using latex strings, and we've got something there called the LDP, which is the Linked Data Platform. It's one of the great BBC three-letter acronyms. It's a data-driven website. It gives option to show all the content. So fairly straightforward. And it ain't broke. So bite size isn't broke, so why would we even think about changing it? So it's well maintained, but it's becoming very, very complicated to make changes. It's incredibly slow to deploy at the minute. It's got a lot of broken cucumber tests, and those become harder and harder to maintain. And we know there are things that we can improve in the bite-sized code base. Like I say, it's difficult to navigate for students. But the architecture just won't let us do that. And to be honest, like I say, it ain't broke. Why fix it? We had the concept of this, though, building a new facet of Bite Size, so the Bite Size app. The Bite Size app is mobile for Android and iOS, and it had the requirements that as a student, I want to be able to personalize content to my needs. I want to be able to choose my country, my language, and my exam board that I'm studying. And I want to have bite-sized and shorter form content, easier to digest for my exams. So basically the idea is that if I'm on a bus going to school, I can do a quick bit of revision, and that's going to help me. And I can test myself on what I've learned, on how well I'm revising. So it's got all the facets of helping you get through your exams. So we're on to some more architecture diagrams. I've got to say, I'm sorry, I really love architecture diagrams, so I'm going to talk you through a few of these. You've got the current website, which I showed you before. We've got all the services coming into our PHP website, but now we want to do the same for a mobile. Now, a mobile can't hope to process as many data streams in the same way. It's going to take us too long to get all that content together, parse it inside the mobile, and we're going to have to build it in two forms. We'd have to build it in Android and iOS, and it's just not practical to do that. And also, you'd be using up a kid's data allowance. Every time you make a data call, you're using up their data allowance, and that's not going to end up with kids actually wanting to use your product. So we created a small node service called Einstein, which we spun up. It didn't take us very long to do. This, from end to end, it was about 3 months. So it's a good lightweight service, and that powers the content of the app. So that allows the app to just make one data call for the pages that it's getting. We used a BBC service called Morph. Morph is a cloud-based system which fetches data from other sources, runs operations on that raw data, and then makes the output of those operations available for consumption. So it aggregates data sources from multiple sources. It was developed by the sport team. I know that those guys have done some talks for Nearform before. It's made to stand up to severe numbers of audience members coming to it at the same time, and it scales brilliantly. Plus, it's got a lot of built-in caching benefits, so it was great for us to use that. And then next, we need to personalize it. So we've got data coming into our app. How do we personalize that? So BBC also has another service called My BBC, which allows users to log in, get their user credentials. And they also have another system called UAS, which is the User Activity Service, another three-letter acronym. The problem with the User Activity Service is it does not store full content, just short-form content, just short codes, so that it doesn't bloat its system, because it's a massive database, just recording what users are doing. So we built another service. We built Newton. Newton, it's a very, very small node service. This was about a month build. It just takes the content from UAS, rehydrates it with content from Einstein, and provides the app with digestible, personalized data that can be used, which is pretty sweet. This is a nice little service-based architecture, and it's got high availability. We don't want it 500ing during exam time. But that doesn't tell you anything about strangulation. Not talk much about strangling at all. What we're doing with the services, though, like Morph and Einstein, is slowly removing the responsibility or the brains of what the application is doing, and we're moving towards code that can work outside of the monolith while leaving the functionality of the original completely intact. So this is the strangler pattern as described by Martin Fowler. What you're doing is you're taking your old code and you're gently replacing it with new code, slowly taking away the responsibility as you go. And the advantage of doing this is you might not know what every part of your old code is doing. I mean, I'm quite lucky. Some of the systems I've got are well documented, but I've worked in other code bases where they're not. And you just know what one part of it is doing. So write one part that takes that responsibility away, and you'll slowly start unraveling it like a piece of string. You'll slowly start getting a better picture of where you are with the old code and the new code. So with this in mind, what can we do with the bite-sized stuff now? Well, we're already getting from a lot of the data from the same sources for Einstein. So what if we started using that to power the web front end too, for preview content? And if we do that, perhaps we can start thinking about taking away the responsibility of the HTML view. We can start shrinking it down. We can start making it smaller, easier to manage. But you've got to be careful there, because Einstein's starting to become another monster. It was built to do one job and do one job well. It was built to power the mobile app, and it does that. So maybe we need another microservice in there. Ooh, was that me? Sorry. Which could then look after the HTML front end. And then once we've done that, we can start thinking about lifting and shifting the code across from the web world into the cloud as well. Because all we're looking at now is HTML, CSS, and JavaScript. It's not a complicated PHP app with unknown dependencies. We've slowly moved those out of its ecosystem. And Einstein and Newton and whatever our new service is, they're small enough pieces of the puzzle to evolve at their own rate and independently of the other elements around them. We can make changes which are transparent to our audience, which allow them to improve the offering. We can start thinking about adding features to the web page. For example, the personalization stuff is something we're really quite keen on getting into the BBC bite-sized website, but at the minute we can't. This would allow us to do it, maybe using Newton as well. We can make changes to the site which are transparent to the user as well. We're not moving anything around. We're not redeveloping the site with a big bang. It's going to be gentle moving across. The teacher is still going to be able to find their old resources. Kids who've bookmarked the site, it's all going to still be in the same place. It's just got other things happening under the hood. Yes, we can do the careful migration of our data as well. This is not a quick process, though. It's something that we're moving living products across, and you've got to be very careful of how this affects your user base. You've got to ensure that you've got good tests in place to make sure that everything you're doing is not going to affect your audience. However, it is time well spent. Simple microservices that can evolve are much easier to manage, easier to maintain, and if necessary, easier to kill off in 5 years' time when they are not doing the job you want them to do anymore. Replace them with something else, strangle them out of existence. Much more towards this way of thinking. So the monolith may not be gone, but it has reduced in complexity. Yeah. And we've got a path down which we know we can move to travel towards to achieve our goals. Right. I've talked far too fast. I do apologize. So I've got some graphs just to show you some more stuff about bite size. So the interesting thing about the bite size app is obviously it's there for kids during their exam time. These graphs show when the app actually launched, and if I can, there we go. There's an advert on the TV at this point just after The Voice. There's an advert there that's just after the Antiques Roadshow, and that one's after EastEnders, and you can see the spikes in traffic as we're getting things through. Another nice thing is, I might have to do this. This is showing, oh, everything's not fine. That's cool. There we go. This is during the exam period, so you can actually see the use of the app going up. So we've got, there would be an exam on this day. This is the weekend, and you can follow it. And it's quite nice to see how users are actually working with your product. And I think finally is that kids are really not very transparent when they leave you feedback on the site. So I thought it might be nice for you to know a couple of things they've said about it. So first one is, awesome. Everybody doing GCSEs needs this to help them revise. I tried every other revision app, and they don't work for me, but this one does. I like that one. Another one. I'm in year 7 and we're doing SATs again. I was told to study for a science test and I want to be a surgeon, which means I need to be really good at science. If I fail, I'll be placed in a low group. I had this app for an hour and I already have more knowledge than I have had in my entire life. Please download this. And as Shia LaBeouf always says, just do it. But you also get things like, why do I want to do homework on my phone? Awesome. Okay, thanks very much for listening. Just to let you know, BBC, we're hiring at the minute. If you're interested in coming and working in Salford as a web developer who gets to work on really cool stuff, please give me a shout. Okay, thanks. Does anyone have any questions? What failures? Ooh. To be honest, when we first launched the food site, because we did a similar sort of pattern with the food site, I think we didn't quite anticipate how much traffic we would get, and we didn't have our caching strategy correct. And so we tried switching from one part of it to the other, we just weren't getting a good experience, and we had to roll back and go back to the old PHP app while we fixed stuff. I think that's been our biggest failure so far. But we were able to work around it. We fixed it. We worked out where our problems were, and we carried on forward with that. Anything else? Okay.
Thank you. That was quite the journey. So I think we have one more speaker for you this afternoon before we transition to lunch, workshops, entertainment, so on and so forth. So while Luca is getting set up, I suppose you're probably waiting for your poem.
I am waiting.
Okay,
for my
yes. Well, let's transition over here, and we'll let the two of them get Luca set up. And while they're doing that, no worries, no worries. All right. PC, TV, tablets, and phones, all in a monolith, which Katie bemoans. Keep bolting on features and the system groans. Scalable, maintainable, reliable, the plea. Lighthouses on islands, floating and free. Bite size is a platform for learning. Oh, gee, but it's quite packed with features and complexity. If we want a nice app from which students will learn, we must reduce all of that data burn. Morph and Einstein and Newton, you see, all part of the mission, modernize the BBC. Progressive enhancement, move gently with care. Don't leave your users wanting to rip out their hair.
Oh, thank you.
Thank you.
All right.
So you ready?
Ready.
All right. So please, warm round of applause for Luca. Take it away.
Hi, everybody. So I'm going to talk about swimming in the microservices ocean. So we layer the monolith, and now we try to see how to scale it. So I work for Nearform, like many of other people here. And you can find me on the internet with my name and surname. That's my handle everywhere. And if I'm not actually traveling the world on an airplane, I'm just spending some of my time working on the postmortem working group. So if you check my talk of last year I was digging my hands inside of core dumps. And then I just saw the light and I moved into distributed architecture. So like everybody working with big architectures, I do have a dream. And this dream is just to build something that is resilient and scalable, and with almost no maintenance. It's actually my dream also at home to have a Roomba or something that can clean my house. But for now, I still didn't achieve this goal yet. So I like actually to tell stories more than to make a demo or anything. I always have bad experience coding on stage. So once upon a time, that's how every fable and story starts, there was the monolith. And the monolith had different kind of shapes. And if you actually go on Google, it's actually pretty funny that if you go on Google Images, one of the first hits that you get is actually this picture that is considered a monolith. So I consider it actually I call it as a joke the Java monolith. And I didn't dare to put the two keys together on Google and see, but I bet with a little bit of money on Google Ads, I can get it as a first hit. But we all know that actually the monolith actually had its own disadvantages. So it was definitely not something that could scale with a high demand of nowadays internet, right? Everybody has a mobile phone, and we all know actually what the iPhone and the Android introduced into APIs market. So because before studying engineering and nuclear physics, I studied at the gymnasium. I studied a little bit of, Latin history. And as you can hear from my accent, I'm Italian. So actually, Philip of Macedonia introduced this kind of incredible strong concept in war strategy that is divide et impera. It means that if you segregate, if you make your things as simple as possible, you can just conquer the world. Well, he did in a certain case. But, so that's actually what the story from the monolith, we move into a next phase that are microservices. And, we have some gurus of microservices down here. But we also all know that microservices all became something trendy and hipster. And, this guy has a beard, he's pretty hipster. So, and one of the key concepts introduced by microservices was definitely the stateless nature of microservices. And one thing that usually, one thing that we're really acquainted with is basically something like this diagram, where basically we have a proxy layer that is most of the time a layer 7 appliance connected with multiple microservices, but they all actually connect to a single source of truth, that is the data storage. So, and we know that actually once that you introduce a single point of failure, that can be your data, you lose actually your resiliency, because your state is going to be anyhow centralized in one single point. And another actually downfall of microservices is definitely service discovery, right? It's an L. There are different strategies, different ways of running service discovery, right? There's DNS, or there's another thing, that is the magic console or etcd. How many of you are running console, by the way, in their microservice application? Okay. etcd? Okay. Well, I don't like either of the two. I really don't like them. They are pretty big. That's actually their main problem. And one of the main key that they still leave open in distributed architecture is the concept of coordination. So, okay, you tell me where I can reroute my request, but there is no way that I can coordinate this request, that I can coordinate all my requests to my microservices. Also because the problem of balancing is still a question, even with service discovery, right? Console doesn't know anything about my microservice unless I don't tell him. And like we said before, actually, one of the biggest problems of introducing mobile client was actually that the insane growth of success of mobile APIs. And actually, this problem was before solved in a very traditional way. How many of you know what this picture is? It's basically, for the other 99.99% of people that didn't raise the hand, is the Google, one of the Google data center. I tried to look for the one of Amazon, but clearly I didn't get any image. And actually, that's when we start to scale horizontally, right? We have high demand, high throughput, and we scale horizontally our machine. But once again, one of the biggest problems of this model still remains the coordination and especially the distribution of our load. So we moved from physical data center and we got the answer, that was the cloud. AWS is the most famous, right? To keep stuff equal, I put one picture of Google and one of Amazon, so I keep both of them very happy. And one of the solutions that actually we see in AWS to scale and to basically solve this problem of coordination and distribution is basically what I call the magical combination of the autoscaling group and the elastic load balancer. Well, if you check any of my other talks, you know that I have a very strong opinion about how stupid is the elastic load balancer. And more recently, Amazon introduced the application load balancer, another masterpiece of stuff that they don't work. But actually, this one didn't solve the problem at all, right? We still scale horizontally, and we don't utilize our vertical resource of our machines. In this path of growth, there was a new disruptor that changed a little bit the world with distribute Node.js application. And this one was the world of container that we saw before with the cruise ship of Costa. And this model actually became extremely developer-friendly, like everybody knows, with Docker. But once again, this one is how usually you deploy on a container environment. This one is the architecture of deployment of Vacamp, if anybody knows, is an e-commerce website. And they use actually a combination of Marathon and Mesos to distribute a container in their infrastructure. But still, the question is always, how do we make it fault-tolerant and resilient? Well, in all these models, the only way that we can make failure detection is still through heartbeat. So we have a system that heartbeat all the machine and says, are you still alive? Are you still alive? Are you still alive? And this model clearly works, but it's not ideal. It doesn't massively scale. So what it leaves still open is that even if I know when a machine is basically up or down, the state of the cluster might change all the time and continuously. It might not be updated in every single node of my cluster. So, and that's where swimming enters in place. So, some bright student from Cornell University came out with this white paper that, how many of you know what swim is? Okay, now I'm going to make somebody mad. How many of you are downloading? No, I ask you later this thing. So maybe the people are leaving and they don't kill me for the question. But Swim is actually gossip protocol. And is acronym states for Scalable, Weakly Consistent, Infection Style, Membership Protocol. So it's actually pretty funny that I could find a word with a meaning that is an acronym of a protocol. So these actually few words, they hide a very powerful way of basically distributing the state across the cluster. We are all living in a weakly consistent world, right? How many of you have a bank account? I hope everybody. Okay. So do you know that actually your bank system is not strongly consistent? Strongly consistent means that in the moment that you process a transaction, the state of this transaction is propagated and consistent across all the state of this transaction. So if you, for example, if you wire some money to me, please do it so we can verify if it really works. You can easily see that the money, they are removed from your bank account and they are added to my bank account. But in between, in all this transaction state, they don't guarantee that the money are really transferred exactly in this moment from A to B. So the transfer from A to B is not strongly consistent, but is actually weakly consistent, which guarantee much more flexibility and speed. And it's a risk actually that nowadays traditional transactional system they can take. And the interesting point is that actually it allows a very simple failure detection over the entire cluster. Because we are gossiping all to each other, the state is continuously moved around the entire cluster. So if I'm faulty, I'm detected by other two nodes that I'm faulty, and my state is propagated to everybody else. It's a little bit like in Italy, we have this kind of concept of the lady that takes care of our basically building where apartments are. And one of the things that actually it's a common way of saying in Italy that if you tell her something, all your neighbor will know this thing. And that's actually the same model as SWIM, right? You tell to one of the nodes something, and everybody else will know about it. And that's where actually the real power of information dissemination comes in place, right? The information is moving all the time across your cluster, so it's never statically pointing to one single place. Imagine that if you set some kind of configuration or some kind of information in a database, a single point of failure, while now the entire cluster is n number of point of failures distributed in this case. And the interesting thing is that you can really play with some interesting load balancing algorithm on the cluster, because clearly if you can distribute the state to every node, every time that you ask to the node the state of the entire cluster, it knows it real time. And the nicest thing is that it's really born for a highly distributed system. It sounds all magic, this thing, but truth has to be told that every time that you add a node to the cluster, how can I rebalance the entire topology? Clearly, imagine I add a node to the cluster, and I need to rebalance the entire state topology. Well, especially I need to redistribute the state and all this kind of complexity. So that's where magic happens at the intersection, they say. So that's when the consistent hash ring meets SWIM, then you can get a highly fault-tolerant state distribute cluster. So how many of you know what consistent hash ring is? At least one person, two, well, few people. Well, it's basically one of the main concepts behind also peer-to-peer connection. So if you are, for example, downloading from BitTorrent, just to make a very concrete example, that's easily how information are distributed and shared across the entire network. Just to make it very simple, it's not really accurate, but just to give you an idea. Imagine that the information is basically sharded and partitioned across the entire network. How many of you are familiar with Oracle databases? I know that I should not mention this name. I will burn in hell for that. So actually, it's pretty interesting because Oracle was the first database to implement a real estate partitioning, which is basically a kind of hash ring, is a shard inside of the database itself. Really powerful, pretty expensive. The nicest thing is, well, like I just said, is that we are just applying the same concept of database sharding, of data sharding, to the entire cluster and information sharding. And this one allows us to basically have a very highly predictable elasticity, because we know exactly how to scale or downscale the cluster and the information. The interesting thing, like I just said before, is that the state is completely distributed. And that's an enormous advantage, because you move from having stateless application to fully stateful application, that they are extremely volatile. So I can add a new node, and the state is automatically rebalanced inside of the entire cluster. Anybody knows the symbol? Because I didn't put what it is. It's Surf. It's from HashiCorp, and they implement basically a SWIM and consistent hashing implementation. So if you're using Console, Console is based on Surf. And basically what I just said is happening also in a cluster of Console machines. Actually, Cassandra used the same mechanism to distribute its data, and DynamoDB. So how many of you are working for Uber? Yeah, I hope nobody. So I tell something new. So Uber actually had the same problem for their dispatch system. So how many of you are using Uber? One person, two, three. Okay, a few people. So when you open Uber and you ask for a cab to come and pick you up to your address, you are hitting a Node.js application that is called the Dispatch API. The Dispatch API is completely based on ringpop. And ringpop is basically their application level sharding library to basically allow extremely fast dispatch information. On the other side of the ocean, somebody that you might have seen a few times on the stage, Matteo, also wrote a library called Upring that does exactly the same thing, but with a big, enormous advantage. That we finally know how it works, because it's much simpler. So ringpop is an extremely big library, and almost nobody knows how it really works, while Upring is extremely tiny, and the big advantage is that it's extremely simple and almost brain dead to implement an application-level sharding Node.js application. So, but what our best friend of Uber did, they actually needed to distribute in an extremely eventually consistent world, that is the world of taxis that are moving around the globe. And just to emphasize what they try to do with ringpop, this one is actually what application-level sharding means. It means that the application itself is responsible of the sharding information. So the application itself knows where that shard is located in the cluster, which is extremely powerful because, like I said before, the rebalance can be done in nanoseconds. In order to do all this thing, Uber had to introduce something. So I'm using Uber as an example because they have something in production, live and running, and everybody's using, almost everybody. They basically had to put an overlay network, because clearly what is missing to all this picture is all the routing and network logic piece. So they built Hyperbahn, but Hyperbahn, unfortunately, is something that nobody knows how it works. So we call it the fourth mystery of Fatima, because nobody really knows how it works. But the interesting part is that the combination between ringpop, so an application-level sharding, and Hyperbahn solve completely the problem of service discovery. That's the only important thing to notice. And in order to speed up the information dissemination and to basically embed the traceability in all this world, they actually create their own protocol. It's a TCP protocol called T-channel, and allows basically to call services through RPC. Do you know what RPC is, right? So we go back 20 years, and that's the world of RPC. But actually, the interesting part, if you read what Matt Sweeney said about T-channel, is that it can easily handle out-of-order responses, because that's one of the problems of distributed communication, is that the order of the response is not guaranteed. And what T-channel can do, it can recompose back all the order of responses in an agglomerated response, which is extremely interesting. And to make clear, this one is a picture to show what happens usually in a TCP communication. There are a lot of cars, there's almost no distribution, there's no coordination. And T-channel actually tried to bound all these points together into a single response. But we mentioned something very important that maybe a few of you are acquainted with in microservice architecture, is actually traceability. So what was a priority for such a large-scale distributed system was traceability of the request. And if you actually go one level deeper, for them was extremely important, because every transaction, it's a financial transaction, so by law needs to be audited. And actually, T-channel is an implementation of a protocol called Dapper, created by Google. How many of you know what Dapper is? One person. One person makes me up. So Dapper is basically just a system tracing protocol. And I highly recommend you, if you are running microservices or distributed architecture, to take down only one name of all the things that I said. That is actually Zipkin. Zipkin is the tracing library written by Twitter for tracing their entire microservice. It's an insanely smart library. It has a complete tracing system behind the scene, so you can basically visualize exactly how the requests are going through all your infrastructure and service architecture. But the question is why Uber went for RPC. And I think it's a very smart decision that I completely agree with. So we go back 20 years, at least. I was very young. And the idea is that we have now so we have a weakly consistent cluster where the information is extremely flat, right? Because every single service owns a piece of its own information and the entire cluster information. And the nicest thing is that we are just calling function inside of this cluster. And Hyperbahn actually acts as a kind of TCP router for all these kind of function calls. And we mentioned actually our best friend from AWS. So AWS has also their own implementation that is Lambda. How many of you are running Lambda? Anybody? Okay, well, one of the problems of Lambda is that I still cannot run it completely offline. So that's one of the questions still how they're going to solve. But we saw that we moved from monolith to microservices to distributed architecture. And the last step and phase of this long living life of services is the serverless world. That is what Lambda introduced. And just to conclude this talk about high scalable distributed architecture, I think actually that this distributed function processing is just the new hipster coming. We see many companies moving into that direction. But I think actually the most important thing is that if we think about, instead of distributing basically network application like web services, but we think how to distribute function, we actually have a very simple development and scalable model that is going to be very easy to maintain, especially very easy to develop. And I think that's actually the future where this large-scale architecture they are ending to. I don't know if they will end or will stop, but that's definitely the direction. And that was my small talk about swimming in the microservices architecture. Thank you. It's in Italian. I'm not going on my knees anymore, because last time the picture went through all my friends' group, so.
Whoops.
Oops.
What wasn't me?
Oh, luckily.
Well, that was just lovely. Thank you very much.
You're welcome.
Please, another round of applause. I know going back with the applaud twice thing. Just beautiful. So I know you're expecting a poem.
I hope no.
No, you don't
wrote
want
it. Yeah.
Okay. Who wants to hear it? Is this the last speaker, I guess? All right. I'm going to try to end it with a bang here.
Okay. With a bang.
With a bang. Hash bang. Luca loves core dumps, but here's another call. He also loves resilient apps, which will not befall the dangers of networks, partitions, and all. Coordination is a question on many a mind, but how do you coordinate a network? Quite a bind. The correct combination of tools you may find is the recipe for success to avoid that sad grind. Failure detection with a fluttering heartbeat, a way to avoid the sting of network defeat. Eventual consistency is the way of the world. For an entire cluster, we see gossip unfurled. Disseminate the info near, far, and wide, and distribute the workload evenly with pride. If predictable scaling is that which you seek, you may want to check out Upbring. Take a peek. Highly available, durable, multiplexed. Quite dapper indeed, no need to be vexed. So go forth, distribute your data, be strong. You now know all the ways you were doing it wrong. So thank you.
Thank you.
And with that, brings me to our last round of housekeeping announcements before we break into the final festivities portion of the event. So real quick, if you have registered for the Kim Carter workshop, ensure that you have completed the necessary prerequisites, installation and whatnot. So see folks at the registration desk for that. We've got a little bit of revised times on that. So the workshops will start at 2. Lunch is starting at 1 p.m. This evening, the gala dinner will be at 8 p.m. at the Old House, not where it was last night. Looks like we've also got meditation and mindfulness at 3:30 to 5 in the Old House. And yes, and the final thing, the most important thing, in terms of announcements, is we will all be going right out here to the left past the registration desk. We're going to do a big conference photo. So if you'd like to be part of that, immediately after this, we're going to go straight over there and do that. And that's it for announcements, but I also would like everyone to give a generous round of applause to all of the folks at Nearform that made this event possible, as well as all of you for coming and making it such a hit. So please, everyone. You're all wonderful. Thank you. See you all for the photo.